This is the homework for 1041 and 1045. For problem 1041, you need to find the volume of a cone shown in the problem 1037. So we have a cone that has a height of 8 inches and a radius of 6 inches. And the formula for the volume of a cone is V equals pi r squared times the height divided by 3. Now, one way to remember this is, this mnemonic device is, veggie pies are too hot, so I need to cut it into thirds. So I'll say it again. Veggie pies are too hot, so I need to cut it into thirds. And hopefully that will help you remind the formula for the volume of a cone. Now if you look right here, pi r squared times the height, that's the formula for the volume of a cylinder. So if you know the volume of a cylinder, you just divide it by 3 to get the cone. So if you remember, veggie pies are too hot for the cylinder, volume of a cylinder, divided by 3 for the volume of the cone. So now we're going to take this and plug these numbers into the formula. So here we have the radius, which is 6, so it's 6 squared, multiplied by the height, which is 8. 6 squared equals 36. And now 36 multiplied by 8 equals 288. 288 divided by 3 equals 96. So 96 pi. So the volume is 96 pi cubic inches. Now that's the exact volume, the actual volume. To find the approximate volume, we can, in the calculator, if we do 96 multiplied by pi, if you use the pi button, you get approximately 301 and 59 hundredths. That's using the pi button. Most problems will ask you to use 3.14 for the approximate value of pi. So if you use 3.14, you get approximately 301 and 44 hundredths. So you can see that there's a slight difference. This is a little more accurate than this one because you're rounding pi to the nearest hundredth. In problem 1045, we need to graph the points -2, 4. So start at the origin, -1, -2, and +4 on the y, 1, 2, 3, 4, and +2, 1. So remember, think of them as hops. +1, +2, and then +1 on the y. And then the third point will be -2 on the x and -2 on the y. So here is our pre-image, this triangle here. And part A is saying, what is the perimeter of the triangle? And so we need to define the distance around the length of these 3 sides. Well, this, we can't just count 1, 2, 3, 4. That doesn't work. You can only count them horizontally and vertically. Those are the units. So to find that diagonal, we need to find the length of this. And I noticed that I can create a right triangle here, and I did it for the blue, to find this angle. And this happens to be a 3, 4, so the legs are 3 and 4. And if you know the rule of a 3, 4, 5 triangle, you know the hypotenuse is 5. And I did the same thing here. I created a right triangle, 3, 4, 5. Because 3 squared plus 4 squared equals 5 squared. Here I'm showing how to do that to find that the legs were 5 or the hypotenuse was 5 by using Pythagorean theorem, a squared plus b squared equals c squared. And the two legs were 3 and 4, so 3 squared is 9, 4 squared is 16, 9 plus 16 is 25 equals c squared. Inverse property of squaring is the square, taking the square root, and those cancel out, and the square root of 25 is 5, so c equals 5. So now that I know this, the length of these are 5, 5 plus 5 is 10, plus 6 equals 16 units. Part B tells me to translate this red triangle here, our pre-image, translate it 2 units up and 3 units to the right. So 1, 2, and 3 units to the right, 1, 2, 3. And I do that for each coordinate, 1, 2, and 3 units to the right. And then the same with this, up 2 units, to the right 3 units. And you can see that this image here, in part C, it's saying, well, what is the perimeter of this? Well, in a translation, it doesn't change shape or size. It just changes the location. Only a dilation would make the triangle increase or decrease in size. So the perimeter of this triangle is still 16 units.